updates is very valuable.
And if your team is great, your team will want those pieces, right? The defensiveness that we know this better than anybody else. Even in a very open project, the individuals are very invested in that stuff. But the value of having other people come in and show you how to do your job better, or tell you that you did a great job, or point you at potential pitfalls mistakes you may not be making now because you've got good practices, but ones you need to make sure that you defend against in process as well as in code over time. And certainly, as Windows said, having access to people who have experience with a really broad a range of applications has been really valuable to us, and I think would be really valuable for anybody that is looking to take their security process to the next level.
It's really easy to get invested in your projects. I think we all really personally invest in our projects, and some organizations fall into the trap of not invented here. So it's nice to have someone come in who is not personally invested, who's got a bit of distance from the project to just look at things and say, like, well, you could do this better. This might be a reasonable another way of going about things that might be better aligned with your goals. We've worked with Modisano, Leviathan, IOActive, ISEC. We are always looking to work with different organizations. So if that's something that your organization does, we want to hear about it. And of course, we use automated penetration testing, and we're going to be talking about some of the fuzzing tools that we use a little bit later. But we find fuzzing to be a very practical approach to looking for vulnerabilities. We're able to target to specific components, to file file parsers, to different image formats. And we use this to identify whether or not an existing library that we're potentially considering incorporating into the system is whether it's squishy or whether it's pretty solid.
One of the important things for us too, especially for a product like a web browser or web server where your entire life is about potentially hostile interactions. The whole of the web for us is code and content we can't trust, is to remember that when people are building attacks, they're not too concerned about whether the page validates. There are a lot of test suites out there that will verify the correctness of behavior according to standards for different kinds of formats or protocols. And those are useful, certainly, in validating the quality of your application, but they have very different coverage behavior from fuzzers, from things that are intentionally hostile. Whether you're capturing existing attacks and figuring out, using those as a base for your testing, or building tools to spread through that potential problem space much more quickly, it is important to keep in mind that perhaps obviously attackers are not going to play by the rules, not only sort of rules of convention, but also rules of the formats, rules of ordering, and those sorts of things. So the depth and breadth of your testing there can have a really significant impact in how effective the technique is for you.
Yeah, they're not necessarily limiting themselves to the RFC, so you shouldn't either. And of course, we do manual penetration testing, and we want to develop test cases to make sure that we're addressing all the areas that we're especially concerned about. And as Mike brought up, we are not just testing. This is not just functional testing. This is negative testing as well. This is not just, is the application doing what we expect it to do? It's what does the application do when it receives data that it's not expecting? And then any issues that we identify, we want to validate them through source code analysis, and that makes some of the source code analysis also a little bit easier to manage, because we're talking about millions and millions of lines of code. And this is also a way to address areas that are hard to do through automated testing. So I talked a little bit about security updates at the beginning, but I think this is actually an important distinction to make, that we are continuously shipping the work that we're doing, all the work that we're doing in security updates on a 6 to 8 week schedule. This is different because we want to make sure that our users don't have to wait for a major release to get the benefit of all the security work we're doing. And that is different from what the vendors are doing, what the other vendors are doing. The problem is you can't see from the outside how many bugs are fixed internally, especially if they're fixed in a large package like a service pack or an update. So it's hard for any environment to ever analyze against another. If you're looking at the number of bugs, to ever analyze against one product to the other, to say, oh, well, there's this number of bugs over here and this number of bugs over there, because you can't actually count the number of bugs in any other environment if everything's not completely transparent.
Giving the updates to users frequently also has had effects, we believe, in encouraging users to update. If you drop a new product on them every 6 years, they have to adjust to all of the changes that have been made there in one go. sometimes in order to preserve the integrity of the application, we need to make changes that may render some sites slightly incompatible, that may, in rare cases, break an extension. And doing that frequently keeps users engaged on a piece-by-piece basis. We can deal, especially with a relatively small organization in a large project, we're able to look at those cases on a much more regular pattern rather than having a huge burst of things to deal with, and potentially difficult interactions between fixed sets once every 3 years, once every 6 years, or even on our major release schedule right now, once every year. So that's been very helpful for us in making sure that we have the ability to make changes that are painful for the application, and we can sort of spoon them out a bit at a time. It's been a lot easier for people to absorb.
So one of the things that you can use to apply this in your own environment is to evaluate whether or not waiting makes sense in your environment. So a lot of vendors do this. A lot of vendors put the security work they're doing into service packs or into major updates because it gets the benefit of a full test pass. And if you are testing application compatibility with 500 applications, that's a pretty serious test pass that you're doing there. But it's reasonable to evaluate whether or not the value of this test pass is required for all these security fixes, and are there some security fixes that can go out in security updates so your users can get them quicker. We've seen some vendors, unfortunately, put security fixes in major updates, and major updates that actually require paying to get this. And that's, I think, if it's a fix and not a feature, right, then it's probably something that should be shipped to everybody, not just the people who are paying for the next major update. Another thing that it's important to consider, and I'm sure it's known for everybody here, but it doesn't seem to be clear to all the vendors, that just because you found it internally a year ago doesn't mean that it's not known externally, that someone else didn't use the same method to find it that you did. So waiting a long time also exposes users to more risk. So if you can get those fixes to them faster, then you've reduced the window of opportunity for an attacker. And it's unfortunate to make your users wait just because there's a ship vehicle coming around in 6 or 9 months.
And that's actually something, we have a 6 to 8 week update schedule, but as some of you may have seen, that doesn't keep us from doing what we think of as emergency updates, where there's a vulnerability that's out of cycle, that's public, that's putting users actively at risk. Recently, 10 days after we shipped 2.0.0.5, we shipped 2.0.0.6 because we found a vulnerability that we believe we needed to address right away. We didn't even want to wait for that 6 to 8 week ship vehicle. Some fixes we'll look at and say they're because of severity or because of they're not being they're not being exploited. These sorts of things, we'll wait for that 6 to 8 week vehicle to amortize some of that testing. But where you need to do something aggressive to keep your users safe, that's something that you consider independently of what your product schedule is, because it's about being reactive in that case, and you need to decouple those things, I think, to keep users maximally safe.
So we're going to talk a little bit about the metrics and how we evaluate whether or not we're being successful in security at Mozilla. So in your environment, you probably have managers asking all kinds of questions that that are difficult to answer, except for the first one: should I be worried? The answer to that one's always yes, right? Are we getting better? That one's hard to evaluate, right? So these are the things these are the ways we're trying to answer some of these questions.
And this is an area also where we are hoping to get benefit from sharing that. One of the reasons we want to talk about what we're doing is not just so that you can avoid having to learn the hard way some of the things we've learned, but also so that you can tell us where we can be doing stuff that's better, where you can share your experiences with different kinds of metrics, with different kinds of measurement, different ways of framing these questions. So for us, this is a process that's is very much ongoing, and one where we're very receptive to feedback and input.
There are a lot of people working on this, like Dan Gear and Andrew Jaquith over at securitymetrics.org. And these are actually really difficult questions, like how do you measure security? These are the things that we're using, and we want to make sure that we're doing reasonable things, first of all, and get feedback from you guys. And if it's something that's useful to you guys, maybe you can apply it in your own environment. But it's a difficult thing, and one of the reasons is that it's hard to I think one of the easiest things to look at is the number of bugs. And for a lot of reasons, just counting bugs doesn't work. Like I mentioned earlier, that you don't actually have a good measure against any other environment. But looking at just bugs doesn't tell you much about the quality of the bug. It doesn't tell you about how fast you're finding them, how bug dense a particular area of code is. And so on, and especially across different projects. I mean, you can use it to evaluate something in your own project, but to evaluate across projects is very difficult because you can't actually count the number of bugs at any vendor unless you can see them from the inside and the outside.
And this is an area where I think the historical focus on sort of raw bug count, right? Stack them up beside each other, see who's shorter, they get a ribbon, has created some unfortunate incentives for people in the behaviors they show and how they report security vulnerabilities. There's a very strong incentive, especially in a competitive marketplace, to be reporting fewer things that make you look bad. We are in an environment where the sooner we look bad, the sooner we are good, and that's been very successful for us. But I think even as consumers of technology, in addition to being developers of it, that focus on only the things that it incents around only saying what you have to about your vulnerabilities, minimizing them where you can, bundling them together to make them, so you're not written up in the press as having 500 vulnerabilities in this one release. Works against people understanding more about the security characteristics of the products they use, and it works against sharing these lessons across the width of the industry. So we're certainly interested in encouraging people to be more explicit about the kinds of things they know about their application security, and we're interested in people telling us where we should be doing a better job. We want to raise the expectations across the industry for how people think about and reason about and compare security of systems.
It should be the kind of environment where a vendor could come out and say, we fixed these 200 bugs. And the story should not be, oh no, product X has 200 vulnerabilities. The story should be vendor fixed 200 vulnerabilities, because that's really, at that point in time, they're fixed, and we should congratulate them for that. But like, that incentive doesn't really exist out there currently. So they are unfortunately in a situation. And if we look at number of vulnerabilities as the primary metric for evaluating the security of a product, we do encourage them to group bugs and to potentially not identify every single bug. So the things that we're using internally are severity, and well, internally and externally is kind of the same thing for us, but is severity, the find and fix rate, how long it takes us to get a fix out there, and how long it takes for our users to get that fix deployed. So we use severity to evaluate what to fix first. We still identify any bug with any level of security risk as a security bug. And just because something has a low severity doesn't necessarily mean that we're not going to address it. But we need to figure out what to do first and how to prioritize. So we assign severity rates. It also helps our users understand how spun up they should get about a particular issue. How serious is this? What is the impact going to be to me? And this is language that can be accessed without understanding all the technical details of a particular issue. There's no standard industry standard, although it seems like every vendor's got their own standard. But for the most part, they're similar. But it would be nice to see if there were an industry standard that we could all agree to. But at least we're consistent with ourselves over time. One of the things that is different about us is that if anything could possibly be considered critical, then we decide that it is critical, because we'd rather not be wrong about this. We'd rather over-report the severity of an issue than under-report it and not have users take it as seriously as they should. So if there's any potential for an issue to be critical, then we consider it critical. Critical means for us that an attacker can run code from remote and there's no user interaction required beyond normal browsing. We consider normal browsing clicking, so if the clicker is required, then we still consider it critical. High is the severity we assign to any issue that allows you to gather any kind of sensitive data or else inject data into those sites, and again, with no special user interaction required. Moderates include issues that are unlikely because of very uncommon non-default configurations, or else require contortions for the user to jump through before the attacker can be successful. And then low includes things like denial of service, because we're a client-side application here. So denial of service, in our case, is like either the browser becomes unusable or hangs, for example, or also a minor data leak that's not personal information or potentially spoofing. So as we're looking through our bugs,